hello guys welcome back to this channel. Samara, let's give a preview about today's. We don't really have a real topic. I'm going to analyze this so-called Big Bang and the theory of inflation. I'm going to propose something like accidental theory, because like for example, in certain conditions or under certain circumstances, matter or changes. For example, if suppose we were to take that we freeze something to minus 273 Kelvin, the properties start to be like, if it's water, it starts to climb the wall, so it changes to something we can't explain why water can climb a wall at that condition. So that is matter, and we don't really know to say matter is energy. And of course, energy is what is matter. Energy is equal to mc squared. And it has weight, and it can occupy space. So if we let's take a case study. Let's take a black hole, for example. That name is suggested, but the phenomena it describes is that thing that attracts everything so strongly, and beyond a certain point you don't see what is there inside there. We don't say inside, beyond a certain point, which we have nicknamed or named event horizon, a point of no return, no man's land, all that. So if the Big Bang took place, under what circumstances or conditions did it take place? What was it really? It wasn't planned, of course. Certain conditions must have evolved to cause that explosion. And if you talk of a singularity where matter is concentrated, does it suggest that before the Big Bang there was matter? Or inflation? When you talk of inflation, right? Inflation, or the space expanding, it's expanding towards what? Because something cannot expand towards nothing. Sorry, there's somebody shouting from outside. It's towards what? And if there is nothing, then it means there's a negative condition. It's noise coming from outside. There's a negative condition outside, and if matter does not exist there, or energy, then it has to be repulsive. So that actually tells us that there could be a boundary to the universe, beyond which a universe cannot, something cannot keep on expanding towards what? If it's towards nothing, it will reach a point where it will start to go back. I mean, how can it be nothing? If it's nothing, there's negative matter is there, negative or exotic. And negative will rebel, because the positive attracts, gravity attracts, anti-gravity should rebel. So if this theory of inflation holds, if it is expanding, it's expanding towards what? Maybe then that's why we suggest that there could be something outside the universe, or other universes, or multiverse universe. Okay? So do you think that this universe is expanding towards something that is unknown to us? or is in a certain formation, maybe rotating something or orbiting somewhere, or it's like a balloon, it expands and contracts. So did it, if you take a Big Bang, was it an isolated phenomena in space, or there were others? A Big Bang holds, how many Big Bang took place? What necessitated the formation of Big Bang? So, for example, if you say we have an atom, you know what's in an atom? We have a neutron, we have a proton, we have an electron, and there's a state of energy which you call valency state, higher energy, low energy. Naturally, when you excite a particle or an electron, it goes to high energy state. There's something in chemistry called valency state. Valency, something like this. This is near to the nucleus, higher energy or higher energy state. Naturally, some electrons would like to reside at the lowest energy level. So if you excite them by some external force like heat or anything, they're subjected to some condition, they jump to higher state of energy, orbit at higher state, but then they'll go back here. In the process, they lose something called heat. So you see, there is a condition that develops, but from where does even the electron? Okay, let's bring in things like Planck's constant, maybe to define this. Something's there which is smaller than even an electron, because a Planck means millions of billions more than an electron. So that condition exists. What beyond the Planck constant? What is there? So I was suggesting the theory of accidental happening, certain conditions that evolved that necessitated a Big Bang, if it ever took place. Right? So I was taking the example of a black hole, and let's go by that and use it to analyze this. Say this is a singularity here. This is a singularity, and around this we have the event horizon, and beyond this we draw a cycle, because it is happening in all directions. It doesn't happen in one direction, like you draw a cone like this. For example, you cannot draw a cone and say that this thing is happening like this, unless this is a cross section. It should be all round, because it's happening in all directions, unless of course there are forces that are preventing that from happening. So we take a black hole, we call it a singularity. We don't even know what a singularity exists, but let's assume there is, because that's what we know. There's a singularity where matter is concentrated at a certain point here, where laws of physics, where space and time is intertwined. Space takes a place of time and time takes space, and there's infinitely compressed, infinitely, and beyond a certain point is a blur. We don't know what happens. Let's even assume that Hawking, we talk about Hawking radiation. If really Hawking radiation exists and the black hole disappear, is a Big Bang anything similar to a black hole? Because maybe there are certain types of black holes which can disappear, instead they regenerate, and maybe Big Bang is one of them. That is maybe, we don't know. Why is it so? Okay, let's go on. So we have a singularity here. I'm not debunking, I'm just being critical. We have an event horizon here, a point of no return. Anything that crosses this line, it goes to a singularity and it cannot come back. And now between here we have a radius, okay, which the German scientists know what is Schwarzschild radius. square shear radius. This event horizon, you know, when something goes beyond event horizon, then it goes for good, it doesn't come back. So around this, let's call this event horizon, where we have time dilation, and then beyond this we have a photon sphere. I'm gonna show you, I'm drawing it. This is a photon sphere. I hope I'm right in spelling. Photon sphere. Photon sphere. Whatever, photon sphere. I don't seem to get the spelling right here. It's a photon sphere here. This point where the photons circulate, because they are massless, they are pulled near actually to the event horizon. They can circulate very, very close to the event horizon because they don't have mass, and they form something like a plasma around it, and then eventually, you know, due to centrifugal force, as the wavelength lengthens, they lose energy and eventually pulled towards inside the singularity. Now, beyond this point, we have the egosphere. Here, the egosphere. These are just names we have given them. Egosphere. Yeah, now I think I'm getting the spelling right of sphere. Sorry. Egosphere. So you see, I'm going up from a singularity where the matter is concentrated here. Here, we assume that this is what really happens. Yeah. So gravitation pull here is very strong, that everything is twisted up. Space and time, laws of physics breakdown, and so on. You're just trying to define, did the Big Bang originate from this type of a situation? Now outside here we have the universe as we know it. Beyond this point, egosphere, we have the universe. Universe. This is all now to the space. So if anything enters event horizon, it's cut off the external universe. Now an observer, this video we did before, who's looking at this thing from this point, who's having a clock here and the clock there are different. And here we have time dilation. Time dilation. Time moves infinitely slow there, due to strong gravity here, which curves space according to Einstein general relativity. Gravity has ability to bend space, and when space bends, time also bends. Okay, so an observer who's somewhere outside seated looking towards, you'll see that something like if you throw an object like you shine a spot of light, it becomes frozen in time at that point of event horizon. So we are not describing a black hole, actually we are talking about the Big Bang. Is this really what happened? Okay, we know. I was trying to give an example because the other theories there were suggesting of a singularity from where everything will rebounds back, that the universe, a big crunch, it start to, dark energy will lose over gravity, or it will act now in reverse. It becomes gravity itself plus gravity and pull everything back to a crunch. I mean, it's called a big crunch. Pull it back, right back to where it started, and become even a singularity from where it rebounds again. You know, that means if you pull anything to a singularity, then it's a black hole. So how is it gonna rebound? So I'm saying maybe there was no energies like these states of energy. We don't even really can define energy, because now if we ask energy, yes, we have potential energy, kinetic energy, we have energy, but an energy is matter. right? Now suppose we assume, now before the Big Bang, where was this energy? What was energy, or was it virtual? Because we know in a vacuum, if we say, okay, it was a vacuum, we have virtual particles in a vacuum which appear virtual particles and annihilate each other within just vanish as fast than their appearance. They annihilate each other, and it's not known whether it's the vacuum itself that behaves that way or those virtual particles are really there. But if there is nothing totally, then virtual particles appear from nowhere. This is what is enigma about the nature of things. Now, to suggest, to support this theory of Big Bang, which occurred 13.8 billion years ago, actually occurred, and there was high radiation, the intense radiation, fast expansion, and then slowing down due to gravity, and then microwave backgrounds that were created, and now gravity slowing everything down, and then stars forming, planets forming from heavy elements in the periodic table, about 2%, and 70% of dark energy was there, that around 3 to 7 billion years ago, it starts to accelerate, right? Now, look at the situation. There was gravity that was slowing everything down. At some point, it accelerated. Maybe there was less gravity and there was no dark matter. Maybe let's assume there's no dark matter, dark energy or dark matter. It's called dark matter. It's only that gravity became less effective and the universe started to accelerate. And then it accelerates more and more, gravity becomes less and less, because now it's supposed to move here from Earth and go to space. What happens to gravity in the stations, even the moon, or in space? We have space stations. Gravity is not there, you can bounce. See, gravity is less. Is that what really happened? What caused the acceleration, or is there really something like dark energy? And if that's what happened, there's no point in time when it will come back to a crunch. It will continue to become even less and less and accelerate. That's just my own thinking. But let's say there was dark energy. Really, there is dark energy, or is it the same gravity that becomes dark energy? Or are these two separate, different things? Gravity and dark energy. We know what's gravity. Gravity is energy. I've told you that. And energy is matter. MC squared, light squared, matter squared. So not matter squared. Sorry. So energy is matter. And now, in this expansion of space, energy is involved. So when you're having gravity creating, when matter is being formed, right? And then the expansion is taking place, more and more matter is being created. Why did the trigger happen? Why is that the universe started to expand fast or accelerate? Is it really accelerating? Or is this something that is always there? When you talk of a boundary in the universe, beyond the boundary, what is there is nothing. Right? What kind of boundary do you have? We have a boundary which is negative, that pushes a positive. Negative and positive attract. So it has to be assumed that at some point the universe may be forming antimatter or negative exotic matter that pushes it back. So it's difficult to say whether this universe is going to last, how long, or it will collapse back, or it never collapse, or okay, let's put away the word infinite, because it does really make sense that something will expand on forever towards nothing. The word nothing really describes a situation that is a space, it's a cosmic. If somebody by magically was to take you and throw you beyond this universe, what would you see there? or what will happen to you. So maybe there's antimatter that will annihilate you. And it's safe to say that actually this universe may not be the only one, because it's difficult to imagine a situation where we have only the dog barking, only one thing happening and not others happening. So maybe there are billions of them out there happening at the same time. But there's this question, but from where did everything start? That's an enigma also. It's quite strange. I mean, something mystery. It can't be explained. So it's good that we are trying very hard to explain these things. But if you take the things, we look around us in nature, we find things behave differently. Like for example, when you say, take for example a diode. A diode allows a forward bias, I mean current to flow in one direction. But we have something called Zener diode, which also at a certain point the current can reverse under certain conditions. So maybe this is what happened in a large scale. So today I thought we'd reason about the Big Bang. I'm not saying Big Bang never took place. It could have taken place, but what necessitated it to take place by molecular soup. And when you talk of 13.8 billion years ago, and we know as early as 46 billion light years away distance, okay, this is the difference between the distance and the actual phenomena that occurred. So the distance has nothing to do with the phenomenon itself. The phenomenon is that, natural phenomenon is that the Big Bang took place. But the distance we are measuring is 46 billion light years ago, when this primordial, that's the expanse of the universe, right? As by the time that is suggested, because it's still continually expanding. And then those primordial energies and high energy states, matter, antimatter, the explosion that took place, expansion that took place. We have neutrons, protons, electrons, neutrons. Yeah, there has to be neutrons also. That's called primordial soup, when everything happened. And why, if we may ask, why did it only happen once? Why can't it happen again? So I'm not debunking these things. I'm only wondering. So if there anybody out there who's watching this video, can you comment about these ideas? Comment about the black holes, we say, which are being formed, the stars that formed, and the rocky planets that formed, and even these periodic table elements which formed. Yeah, we know how stars are formed. The stars, dust, and the energies and pressures that accumulate, and then these things are formed. So anyway, I was trying to draw this, and you can at any instance say this is a black hole, and it can also be the space itself, the universe, and the big range will be there when these things start to go off towards a singularity, and all less Hawking radiation holds. Hawking radiation is subject to analysis, because if really this black hole disappear, where does the energy go to? What about the information paradox? The information that went there, where does it go? Yeah. Yes, guys, thanks for listening to me talk about my favorite subject, about the universe. What is there? Does it ever wonder? Do you ever wonder what's the universe? Or do you even wonder who are you? I don't want to introduce so many things into this topic. Let's stop it there. Thank you for watching. Please subscribe to my channel, and let's travel this journey together. If you have very nice, good ideas about this topic, please suggest, give me some thought about this subject. Yeah, man. Thanks for listening. Please share, like, and subscribe to this critical analysis video. So Sorry. Bye. Please share, like, and comment, and subscribe. Don't forget to subscribe to this channel, because your subscription will make it to be there. Otherwise, you're gonna go. One day you wake up and you don't see these videos anymore because the channel has to grow. It's your effort, your participation in this that will make us continue. Bye. See you later.